Alright, greetings ladies and gentlemen. This is our cruise's project number 17 and we call it as the Arduino Smart Greenhouse. So this thing is a kind of system, an automated system for a greenhouse that we use Arduino microcontrollers for. So what microcontrollers are usually used widely for agricultural purposes, and mostly for that. So we use them to optimize plant growth as in general, by monitoring and controlling its environmental factors. So we should take things like temperature, humidity, soil moisture, light intensity, and the air quality inside as well. So we will use and incorporate sensors to gather data and its actuators and its information to adjust its conditions. Differs on specific plants, ensuring the ideal environmental for plants. So this setup actually reduces human intervention and can also include remote monitoring and control, reducing work labors, and which making it suitable for both hardcore hobbyists and serious commercial growers.
So, the objective of our project is to promote the use of Arduino in smart greenhouse, to fully understand Arduino and its function towards smart greenhouses, to develop an automated and sustainable greenhouse system to produce high quality yield, to ensure optimal condition for plant health and growth, to identify the appropriate design for the yield, and lastly to reduce the burden of greenhouse caretaker in managing the area with the help of Arduino.
For this project, we use Arduino Uno as the main controller. The Arduino collects data from two sensors, which are DHT11, which measure temperature and humidity. The other sensors are MQ135A quality sensor, which detect harmful gases like carbon dioxide, ammonia, and smoke. These real-time readings are then displayed on 16 by 2 LCD screen with an 12C interface, making wiring simpler by using just two communication lines. To respond to changing air quality, we include a relay module, which acts as an electronic switch, allowing the Arduino to automatically control devices like fan or air purifier. All components are connected with jumper wire and assembled on a breadboard, making it easy to test and modify the circuit without soldering. The entire system is powered by a USB cable or a battery pack, making it feasible for both desktop and portable setup. So now for the procedure. First, we connect the DHT11 sensor, VCC to 5V on the Arduino, GND to GND on the Arduino, data pin to digital pin 2 on the Arduino. Second, we connect the MQ135 sensor, VCC to 5V on the Arduino, GND to GND on the Arduino, analog output to analog pin on the Arduino. The third step is connecting the LCD display, SDA to A4 Arduino, SCL to A5 on the Arduino, VCC to 5V on the Arduino, GND to GND on the Arduino. The second step is to connect the relay module. First, VCC to Arduino 5V, GND to Arduino 5V, control pin to digital pin 8 on the Arduino, COM and NO terminal to the device that was to control such as fan or heater. The last step is to connect the fan to the relay module. VCC or 5V on the Arduino go to the COM, GND to NO on the relay. Positive fan to COM on the relay, negative fan to NO on the relay.
Our model is made using a recycled material such as plastic, sticks, and also cardboard as a base. The plastic is transparent and also strong and waterproof, which makes it perfect for letting sunlight pass through while protecting the plants from the rain. Cardboard is used because it's lightweight, easy to cut and shape and also serve as a good foundation for the model. The structure also includes a small window to allow fresh airflow in and also out, and also help to keep the inside cool and well ventilated. Inside our model also, sensors are added to monitor temperature and also soil moisture. These sensors help us understand the growing conditions and how they affect plant health. While the watering system is done manually, we still learn how to observe plant needs and also water them correctly. The model also uses a simple switch or app to show how smart system can control parts of the greenhouse in the future.
And today I will be discussing about our smart greenhouse project. The main goal of this project was to create a simple yet effective monitoring system that can really help to maintain the optimal conditions for our plants' growth. In our setup, we use an Arduino microcontroller such as DHT11. Apart from that, we also use the second sensor, which is the soil moisture sensor. Lastly, we also implement a sensor such as MQ135, which is an air quality sensor. So initially, we plan to include a water pump in our smart greenhouse. However, due to some technical issues, we were unable to fully implement the component. Instead, we achieved to implement the mini fan in our smart greenhouse project. For the water pump, even though we are unable to implement the water pump, we can control it by watering the plants manually. So throughout the project, we collected the data for about a period of 7 days. The soil moisture readings showed a gradual decrease over time, which is expected as water evaporates from the soil and is absorbed by the plants. On day 6, there was a slight increase, likely due to manual watering. The air quality values remain fairly stable, indicating that the mini fan was effective in maintaining a good ventilation. As for the temperature, the readings range from around 28.5 to 30 degrees Celsius, which show a consistency in indoor condition throughout the week. In the future, we plan to improve the system by fully integrating automated watering system, and can also put solar panels that really helps to boost the electricity of our smart greenhouse project.
In conclusion, we will glad to introduce you our project, which is Smart Greenhouse. This project will help overcome all the problems we discussed earlier, which is it will help to maintain the water, soil, pH, and also find a suitable temperature for the plant. In addition, this project will lighten the burden of human to take care of the plant while promoting high yields and healthier plant. We hope that our innovation can develop rapidly so that it can be used by all countries, whether they have seasons or not. That's all from us. Thank you.